Assalamualaikum and good morning. I'm Teacher Nick. Today I'm going to teach a topic from Science Form 2, topic number 7.1, electricity. Energy plays a very important role in our daily life. We use energy in almost all the things we do, including cooking, washing clothes, for entertainment, watching TV, and also in our workplace. For example, to power a computer, or the lights and the fans. Energy also enables plants to carry out their photosynthesis. Energy also needed by the non-living things such as car, motorcycle, and television to make them functioning. This topic starts with a discussion about energy. By definition, energy is defined as the ability to do work, and the unit used to measure energy is joule. There are various forms of energy existed in this world, such as kinetic energy, light energy, heat energy, potential energy, nuclear energy, sound energy, chemical energy, and not to forget, electrical energy. Kinetic energy is a form of energy that possessed by a moving object. It depends on the speed and the mass of the object. For example, for the fan, when it moves, that is kinetic energy. When a person walking, that is kinetic energy. When a person is dancing, that is kinetic energy. When the wind is blowing, that is kinetic energy. Heat energy is a form of energy that is stored in hot object. For example, human body is hot. It possesses heat energy. Other obvious example like a sun, a very hot object, it possesses heat energy. Fire possesses heat energy. And also anything, when you touch, you feel the heat, it possesses heat energy. The next one is potential energy. Potential energy is a type of energy stored in an object due to its position. There are two types of potential energy. The first one is gravitational potential energy. It is due to gravity. And the second is elastic potential energy. It is caused by the elasticity. Next is nuclear energy. It's an energy stored in the nucleus of an atom. There are two ways to produce nuclear energy. The first one is by nuclear fission. And the second one is by nuclear fusion. Next is sound energy. Sound energy is a type of energy produced by vibrating objects. For example, the human voice is produced by the vibration of air inside the human vocal cord. From the vibration of the strings for the guitar and violin. The drumming sound comes from the drum, comes from the vibrating surface of the drum. Chemical energy is a type of energy stored in substances, for example, fruits, vegetables, and fluids. Light energy comes from the object that radiates light. And last but not least, electrical energy. It's a type of energy produced from the moving charges in electric conductor. Before I discuss further about the electrical energy, you need to understand that electrical energy is a type of energy that is not naturally available. It must be generated by using an electrical generator. And the electric generator needs energy from the other sources to give them a push to produce electric energy. There are numerous sources of natural energy on this earth. that can be used to generate electricity. For example, water, sun, biomass, geothermal, wind, waves, fossil fuel, radioactive substance. Electrostatic charges is a study about electric charges that are static, or in other words, not moving. There are two types of electric charges. The first type is positive charge, and the second type is negative charge. Electric charges are produced when we rub two different types of insulator. For example, polythene rod and woolen cloth. When two insulators are rubbed together, electrons will be transferred from one object to the other object. Insulators such as polythene rod, acetate cellulose strip, and balloons are types of objects that are easily charged when rubbed with woolen cloth. For example, when you rub polythene rod with woolen cloth, the electron bonds in the object will loosen, and one of the object will lose the electron while the other object will receive the electron. Objects of the same charges will repel each other, while objects of the different charges will attract each other. The attraction and repulsion of these charged objects will cause electrostatic force. The example of this electrostatic force can be observed when you rub a balloon to your hair. The balloon will become negatively charged because the electron from the hair strand transfer to the balloon, and at the same time your hair become positively charged because it loses the electrons. Since opposite charges attracts, where the balloon has turned negatively charged and the hair has turned positively charged, you can see that your hair is attracted towards the balloon when you place the balloon near your hair. This is the effect of electrostatic force. The presence of electrostatic charges can be detected by using an electroscope. The electroscope that is commonly used is the one with the gold leaf. The electroscope with the gold leaf is made up of a flat metal plate, gold leaf, metal rod, and an insulator. When a charged rod is brought close to the copper plate of the electroscope, the gold leaf would rise. This is because the charged rod has induced charge on the copper plate, the metal rod, and the gold leaf. And because the gold leaf is very lightweight, when it is charged, it will rise due to the repulsion effect between the metal rod and the gold leaf. Now let's talk about the application of electrostatic in daily life, the phenomenon of lightning. During a windy and cloudy day, the cloud in the sky is drifting very fast, and there's a lot of frictions happening between the clouds and the wind in the sky. Due to this friction, the charges in the cloud polarize or separate. The positive charges gather at the top of the cloud, and the negative charges gather at the bottom of the cloud. Since the negative charge is too intense at the bottom of the cloud, they have the tendency to discharge. This is when the lightning occurs. During the lightning strike event, there's actually attraction force between the positive charge on the ground pulling the negative charge at the bottom of the cloud down to the earth. Okay, that's all about electrostatic. Now let's move on to electric current, voltage, and resistance. Electric current is defined as the rate of flow of electrical charges passing through a point in an electric conductor. The flow of electric current can be measured by using a device called ammeter connected in series in an electric circuit. The SI unit for electric current is ampere. Electrical voltage. Electrical voltage is a measure of electric potential difference between 2 points in an electrical circuit. Voltage passes through a conductor in a circuit can be measured by using a voltmeter. The SI unit for voltage is volt. Now let's talk about electrical resistance. Electrical resistance is the ability of a conductor to resist the flow of electric charge in a conductor. The unit used to measure resistance is ohm. When the resistance in an electric circuit is high, the flow of electric current becomes low. The value of electrical resistance in an electrical component depends on various factors. For example, the types of material, the length of the conductor, the diameter of the conductor, and the temperature of the conductor. A poor conductor has a very high electrical resistance. It means it will allow only a small amount of current flowing through it. While on the other hand, a good electric conductor has a very low electrical resistance. It means it allows more current to flow through it. Once you understand about resistance, it's time to talk about resistor. Resistor is an electrical device used to limit the flow of electrical current in an electric circuit. There are two types of resistor. The first one is fixed resistor, and the second one is variable resistor, or we call it rheostat. Fixed resistor has a fixed value of resistance, while the resistance in a rheostat can be changed as desired. The current, the voltage, and electrical resistance are three physical quantities that are related to one another. The change in one of the physical quantities will cause the other two physical quantities to change as well. For example, when the value of resistance in the circuit changes, the value of the voltage and the electrical current in the circuit also change. The law that relates current, voltage, and resistance is called Ohm's law. Ohm's law states that the amount of current flowing in an electrical circuit is directly proportional to the amount of voltage across the circuit, provided all the physical conditions of the circuit stay constant. Ohm's law can be stated mathematically by using the formula V equals to IR, where V represent the voltage, I represent the current, and R represent the resistance. This Ohm's law formula can be used to determine the value of voltage or the current or the resistance in the circuit. When you have a bulb with 5 ohms resistance, receives a voltage of 1.5 volts, calculate the value of currents flowing in the bulb. In my next video, I will show you calculation examples on how to use Ohm's law to find electrical current, voltage, and electrical resistance. Until then, stay tuned to Science di Mana-Mana.